All right, everybody, we're on page 331, lesson number 7. This is a very short lesson. It's basically getting used to identifying what graphs, the general shape of a graph based on its degree. So, quick review from the last lesson. If you remember, the zeros of a function, the x-intercepts of a graph, and the roots of the equation y is equal to 0 are all the same numbers, which is basically to say these numbers right here, the x-intercepts. If you know the x-intercepts, you can write function in factored form, which is what we're going to start today. This is a general way to write a function in factored form. C, which is the leading coefficient for this lesson, will be plus or minus 1. We'll deal with it when it's not 1 later on. And then the factors, or the zeros, of this general function are what make each bracket 0. So in this case, it would be a1, a2, a3, etc. All right, so we start with this polynomial function, x cubed minus 2x squared minus 5x plus 6. This is the graph. They want us to write it in factored form. You can see that we have x-intercept is -2, 1, and 3. So the zeros, obviously, -2, 1, 3. The factors, that's where you write the brackets. It's always x minus a when you write a factor, a being the zeros. So in this case, it would be x minus -2, which is actually just x plus 2, x minus 1, and x minus 2. Those are your three factors. And because we know the leading coefficient is plus or minus 1 for all of these, okay? And the reason you know that is because I've told you that. Then we write the factored form of this polynomial is x plus 2. You just write all the factors multiplied together. X minus 1, x minus 3. All right? And since the leading coefficient here is positive, you could put a plus 1 there, but it's no need to if it's positive, so you can just leave it. All right. So basically what we're saying is if you have a sketch of the graph and you have the x-intercepts, you can figure out how to write the polynomial in factored form. So what if you just have the polynomial and you want to factor it? Well, you could do what we did last time, find all the possible factors of the constant term, divide by all the possible factors of the leading coefficient, and blah, 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 and go through there, and that do your division, and that takes a while. Or you can graph it. So, which is what this lesson is going to teach us. So if I take this graph and I go to Desmos, okay, and I enter this graph in Desmos. So negative power of 3 plus 4x squared plus 7x minus 10. So there's my graph, okay? You can see, I screwed that up. Supposed to be a 4 there. There we go. Oh my gosh. Sorry, everybody. There we go. There's our x-intercepts, okay? And so -2, 1, and 5. So going back here, -2, 1, 5. We know the graph looks like this. Don't worry about how high these maxes and peaks are. There's no y value on this graph. I'll show you in a sec. There is one that we can determine. But the x-intercepts, -2, 1, 5, write the polynomial in factored form. So that is essentially saying, right, x minus a1, x minus a2, blah, 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 blah. So we go p of x is equal to x plus 2 x minus 1, or x minus 5, x minus 1. And the trick here is since the leading coefficient is negative, you must put a negative there. Also, on the graph, if you look at this point right here, go back to Desmos for a sec here, that is a point of negative 10. This is the same as the constant term over here. So this we can mark as negative 10. Whatever the constant term is, will be your y-intercept. Okay, because if you put x is equal to 0 into everything, they all go away. And you're left with negative 10. And if you look back here, y-intercept was 6, constant term out of 6. Okay, and just like on this one, we said the leading coefficient was positive, so you could put a plus 1. This one, since it's negative, you must put the negative there. All right. Some general sort of observations. I don't like the notation here. The left arm is up. The right arm is down. The degree of the polynomial, so the highest exponent, is odd, it's 3. And the leading coefficient, we just said, is negative. Okay, the questions I want you to do, and I'm going to do one of them with you. E to J, number 1, E to J, number 2, A to F. And what I want you to do is use Desmos and graph the polynomial and write it in factored form. So I'll do F with you. Okay. So you're going to go to Desmos or whatever graphing calculator you want to use. Clear it all. And we're going to go negative x to the power of 3 plus 7x squared minus 7x minus 15. So there's our graph. We have x-intercepts of negative 1, 3, and 5. We can check to see if our y-intercept, negative 15, which matches that, so we're good there. So then what we're going to do is go back, negative 1, 3, 5, like that. I'm looking for general shapes here. We know that number is going to be negative 15. To write it in factored form is going to be x plus 1, x minus 3, x minus 5. And since the leading coefficient is negative, we put a negative there. That's all I want you to do for each question. Okay? Hopefully you will pick out a trend. So then I wait, you hit pause on this video, and then the summary. This is the important part of this lesson. Okay? This is what you need to remember going forward. So, if your leading coefficient is positive, okay, and it's an even degree function, then your graph will look like something like that, or the parabola shaped like that. The key is here, people, is both arms are up. Both arms are up. Okay? You can see the left arm and the right arm are both up. If it's an even degree, both arms are up. If it's leading coefficient, even degree and leading coefficient positive, both arms are up. If it's even degree and your leading coefficient is negative, so even degree, so even degree, and I'm going to shorthand leading coefficient as LC is negative. So you've learned from the exercises that I assigned, both arms will be down. And the number of bumps here is going to be dependent on the actual degree. All that matters is that it is even. Okay? So by even, x to the power of 2, x to the power of 4, the power of 6. All right, any even. All right, so both arms are down. Both arms are down. Basically, when the degree of the function is even, the arms are in the same direction. The left and the right arm are always going to be in the same direction, either up or down, and that's going to depend on the leading coefficient. All right, if we have an odd degree function, okay, if it's odd, so it's x cubed, x to the 5, x to the 7, etc., arms go in different directions. Okay, so odd degree functions, and we'll talk about the coefficients in a second, like that, or, and again, number of bumps depends on the degree, right? But the arms go in different directions. Now, if it's odd, and your leading coefficient is positive, okay, then the right arm is always up. It looks like this. Right arm is up. Okay. If the leading coefficient is negative, and it's an odd degree, and big guess here, the right arm is down. That's it. So if you remember that if you have an even degree function, all right, arms are in the same direction, either up or down. It will be up if you have a leading coefficient that is positive. It will be down if your leading coefficient is negative. If you have an odd degree, all right, the arms will go in different directions. If the leading coefficient is positive, the right arm is up. And if the leading coefficient is negative, the right arm is down. That is what you need to remember from this lesson. Okay. I hope that makes sense. Email if you have any questions. Very short lesson. I'm going to post number 8, probably this and number 8 together because they kind of tie in together. All right. Good luck. Thank you.